In this problem, we're given a cubic polynomial with two unknowns, which we have to find. And we're going to find them using the remainder theorem, because we're given that this is a factor, and that when we divide this polynomial by this, we get 4 as the remainder. Now, when we say that something is a factor, it means that when we divide the polynomial by x plus 2, we get remainder equals 0. Now, if we rewrite the polynomial simply as a function, including the unknowns, as 3x cubed plus px squared plus qx minus 2, the remainder theorem says that we take the factor, or rather the thing we're dividing by, and you take the opposite of whatever is together with the x. So in this case it would be minus 2, in this case it would be minus 1, and then you plug this opposite into x of the function, and then you set it equal to the remainder, which is left when we divide the polynomial. And so if I put in f of minus 2, what's with my pencil? F of minus 2 is going to be 3 times minus 2 cubed plus p times minus 2 squared plus q times minus 2, and then minus 2. Now this has to equal 0, because the remainder, because this is a factor, the remainder when we divide this polynomial by x plus 2 is 0. Now that's the remainder theorem. Now we also use this piece of information to get two equations which we can then solve. Two equations, two unknowns. So f of minus 1 is then going to be equal to 3 times minus 1 cubed plus p times minus 1 squared plus q times minus 1 minus 2, and this then is going to have to be equal to 4, because that's the remainder left. Blah. That's the remainder. Now we have two equations, and let's just simplify this a little bit so that we know what we're dealing with here. The first equation is going to be minus 24 plus 4p minus 2q minus 2 is equal to 0. And the second equation is going to be minus 3 plus p minus q minus 2 is equal to 4. Now this is just simultaneous equations. We solve this simultaneously by rearranging the equations, and this of course is a lot easier. I have to get a new pencil. 2p minus q is equal to 13, and p minus q is equal to 9. Right, I've just rearranged them, subtracted stuff, added stuff, and this gives that p is equal to 4 and q is equal to minus 5. And this here is our answer.